In this video clip, we are going to begin exploring algebra. We will begin with reviewing some necessary vocabulary, and then we will venture into solving numerical expressions by using order of operations. So let's begin with vocabulary that we'll be using in algebra this school year. And it will be the basis to all of the algebra that you will be using through middle school and high school. Mathematics. So algebra is an area of mathematics that uses letters and symbols to represent numbers and quantities. An algebraic expression is at least one number, an operation sign, and at least one unknown number represented by a variable. There is no equal sign. In this example, we see that x is represented here, and they're calling it a symbol. But x in this equation, this expression, because there's no equal sign, x is representing a number that we don't know, so we call these variables. Then we have the numbers, and then we have the operation signs. A numerical expression is a combination of numbers and at least one operation. And you will see 4 examples written here. You will notice that there are a set of parentheses in 3 of these equations or expressions. And anytime you see numbers and operations inside of a set of parentheses, we call that a quantity. Operations are addition, subtraction, multiplication, and division. Variables are letters that are used to represent a number in an equation or in an expression. For example, the variable x represents any kind of number from negative infinity to positive infinity. In this equation example you see here, 1 plus x equals 3. X is a variable that represents an unknown number. And if we were to think about what we could put as in place of that x to make this equation true, it would be the number 2. We see some other examples of variables x and b and y, and we see them placed in these algebraic expressions. Now, the most used variables in algebra are x, y, n. I don't know if there's so many of them, but x, y, and n tend to be the 3 that are most often used. We don't necessarily see the letter O being used to represent unknown numbers because O looks so much more like the numeral 0, so we tend to stay away from the letter O for a variable. When using the letter T as a variable, we need to make sure that the T has a hook on the bottom of it, because if we don't, it will look like a plus sign, an addition sign. For the letter L, we also give it a hook, because if we don't, it looks like the numeral 1. An equation is different than an expression in the fact that on both sides, the equation has an equal sign, and it says that 2 amounts on each side of the equal sign are equal. They're exactly the same amount. So you will see here in this first example, on the left side of the equal sign you have 2 plus 5, and on the right side you have 5 plus 2. Both sides are exactly the same amount. On the left side of this, in this example, we see 2 plus 2, which is 4. And on the other side of the equal sign, we see 4. And we know that both sides are exactly the same amount. So these are equations. Here is a good example showing and labeling all parts of an algebraic equation. So we have a number 3 and then the variable x. We call a number next to a variable a coefficient. Actually, a numerical coefficient if you want to be exact. And remember, anytime you see a numeral next to a variable and there's no operation symbol between them, it's automatically always multiplication. So in this case, it's the same as saying 3 times x. When we put 3x and add it to 6, this entire side of the equal sign is called an expression. And on the right side of the equal sign, that 12 is also an expression. When you put them together with an equal sign between them, the entire thing is called an equation. So this is how we need to know the difference between an expression and an equation. Expressions do not have equal signs unless you've been asked to evaluate them. If you've been asked to evaluate them, as we will see later on when we perform order of operations on numerical expressions, you will see when the equal sign takes place. Now, let's talk about order of operations. This is a set of rules that we follow in order whenever there is more than one operation used in an expression. We follow a specific order of performing operations in numerical expressions when solving them. But before we begin to do that, we need to know that there are usually 3 types of grouping symbols used in some of our numerical expressions. They are parentheses, brackets, and braces, and they're all different forms of parentheses. And there is an order to using those. Whenever you see grouping symbols used in numerical expressions, the parentheses are always performed first, brackets are performed second, and then braces are last. And only if they are present in the numerical expression. But it's always parentheses first, brackets second, and braces third. When we solve equations algebraically, we use the order of operations. And there is a specific order that we follow. We have an acronym, PEMDAS, and a lot of people pronounce this PEMDAS. And it specifically tells us what order we must follow when solving equations algebraically. We remember PEMDAS by using the little saying, "Please excuse my dear Aunt Sally." The P stands for parentheses. Those are performed first. Remember, if we have more than parentheses, we have the other grouping symbols. Parentheses are always first, brackets are second, and braces are third. Once parentheses have been performed, we look into our expression to see if there are exponents or roots. If there are, exponents are evaluated second. Once we've done parentheses and exponents, then we move on to multiplication and division. So we would multiply and divide, always beginning at the left and moving to the right, and we always perform whichever operation comes first. Because we say multiply and divide in that order, and it comes in that order in the word PEMDAS, we don't necessarily always multiply first, and a lot of 5th graders will get confused by that. Sometimes division appears in an equation first, and if that are the case, that will be performed before any multiplication, left to right. Whatever we need to perform, it's always done left to right. Once we have satisfied ourselves with solving the equation with parentheses first, exponents second, and multiplying and dividing left to right third, then we lastly and finally perform any operations adding that are addition and subtraction, and we always perform those left to right, whichever comes first. If adding comes first, we do that. We perform that operation. If subtraction comes first, we perform that one before we do any adding. Now, just to review real quick, grouping symbols are symbols used to group numbers. Parentheses are always done first. Brackets are always second, and braces are third. Whoops, I noticed this is written incorrectly up here. So this should say brackets is second, and braces are third. Oy, oy, oy. Sorry about that. Now let's do a quick review of exponents. We talked about this when we were doing powers of 10. Exponents are the little numbers that are in the top right corner of a number. That is called an exponent. It also has 2 other names. index or power, and this indicates how many times the base is used as a factor. The base is that bigger number that we see right here, and it's the number that is used as a factor. So a lot of students will say that this is 6 to the third power, and they'll say, oh, that's the same as saying 6 times 3, which is 18, and that is totally incorrect. So what it is we take that 3, that exponent, and say to the base, multiply yourself by that 3 times. So it would be 6 times 6 times 6. Here's another example of 2 to the 4th power. And that's that little exponent says to the base, you multiply yourself as a factor 4 times. So 2 to the 4th is the same as saying 2 times 2 times 2 times 2. So that's the same as 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power is 16. Some students will write 2 times 4 is 8, which is incorrect. So 2 to the 4th is 16. It's not 8. Here's another example with the base being 5 and the exponent being 3. The little exponent 3 says multiply the base by itself 3 times. So that's the same as saying 5 times 5 times 5, which is 125. Not 5 times 3 is 15. All right. I have a really cool strategy that you can use to solve algebraic expressions. This is called the bridge strategy, and it will help you organize and solve your problems easily. And it will make sense to you as we work through these. We're going to start with some easy problems and work towards some more difficult. And I put my little PEMDAS pyramid here to help us remember the order. Parentheses first. Remember, parentheses first, brackets second, braces third. Exponents are second. Multiply and divide left to right, whichever one comes first. And add or subtract left to right, whichever one comes first. So let's begin with this first problem that we see here. So I have 3 times the quantity 4 plus 5. So in order to solve it, I have to follow the order of operations, and according to the order of operations, parentheses come first. And in this problem, I do have a set of parentheses. So I'm going to draw a bridge underneath that set of parentheses, that quantity. And I'm going to put my equal sign underneath, and anything that's not on the bridge is going to fall down, because if you're not on a bridge, you fall down to the next level. So the 3 comes down, the multiplication symbol comes down. Now I'm going to perform what's on the bridge and bring it down. So 4 plus 5 is 9. Because I performed that, the parentheses can now go away. So I did parentheses first. Then I'm going to do exponents second. But in this problem, there are no exponents, so I can skip that step. Then it says to multiply and divide left to right, whichever comes first. And I notice here that there's multiplication. So this is my next bridge. So I'm going to perform what's on the bridge, and anything that's not on the bridge comes down. Well, here there's nothing left over that's going to fall off the bridge. So we're going to put our equal sign down below it, and these stay lined up so we keep our solution in a neat, organized manner. So 3 times 9 is 27. And there is my answer to the numerical expression, 3 times the quantity 4 plus 5. All right, let's take a look at this one over here. So we're going to perform parentheses first, and I always start on the left, so this set of parentheses is going to go first. Some students will ask, can I do both sets of parentheses first? Well, it all depends. Sometimes it works out. Yes, you can do that. Sometimes it may lead you to an incorrect answer. So I usually just do left to right, one at a time. So this is the first bridge I'm going to draw. So I'm going to perform what's on the bridge. So 14 divided by 2 is 7. And whatever's not on the bridge comes down. The plus sign comes down. And then this quantity, 6 times 2. Okay, I'm still with parentheses, so I need to do more parentheses. So I'm going to draw a bridge here under these. Whatever's not on the bridge comes down. 7 comes down. Plus sign comes down. Quantities, now I'm going to perform what's on the bridge. So 6 times 2 is 12. Okay, and now I'm done with parentheses. Next I have to do exponents, but there are no exponents here to perform. Then it says to multiply and divide left to right. There is no multiplication and division. So no, finally I'm on addition and subtraction. Oh, yes, there's addition. So I'm going to draw a bridge here. And I put my equal sign directly under. They're all lined up so I can keep everything in a nice, neat, organized manner. Perform what's on the bridge. 7 plus 12 is 19. Nothing else is left on the bridge. I'm finally done with the last step. There's my answer, 19. All right, let's look at another problem. We're going to do this one over here on the left. So it says, parentheses first, there are none. So I'll move to the next step, exponents. There are none. So now I'm going to move multiply and divide left to right, whichever comes first. So in this case, when I started on the left, multiplication came first. So I'm going to draw a bridge here and begin. So I'm going to perform what's on the bridge. So 3 times 2 is 6, and everything else that's not on the bridge falls down to that level. Now I need to see, are there any more multiplication and division? Yes, there is right here. So that's where I'm going to draw my bridge. These two are going to be divided, these two numbers. So I'm going to put my equal sign underneath, keep it lined up. Whatever's not on the bridge falls down, and I perform what's on the bridge. 4 divided by 2 is 2. These fall down because they're not on the bridge. Now I have no more multiplying and dividing, so now I move to the next one, adding and subtracting, left to right, whichever comes first. So if I look up here, addition comes first, so I will be drawing a bridge there. Put my equal sign underneath, perform what's on the bridge, so 6 plus 2 is 8, and whatever is not on the bridge falls down to the next level. Now I have subtraction left, so that's what I'm going to do last. Put an equal sign, and 8 minus 2 is 6. There is my answer. Now let's perform this algebraic numerical expression. Parentheses are first, there are none. Exponent is second, there are none. Multiply and divide left to right, whichever comes first. So I have division and multiplication, but if I work left to right, division came first because it's on the left. Multiplication, just because it's first here, it doesn't matter. But if you look here, the flip-flop, you can go either multiply or divide first. So here is division first. So whatever's not on the bridge comes down to the next level. Perform what's on the bridge. So 30 divided by 15 is 2. And then whatever's not on the bridge comes down. Now I notice that I have multiplication and I'm still on this third step. So I'm going to put a bridge under 2 times 3. Equal sign under whatever's not on the bridge comes down. Perform what's on the bridge. No more multiplying and dividing. So now I move on to add and subtract left to right. And what's left is 7 plus 6, which is 13. And there's my answer. Oh, look, now we're moving into using parentheses, braces, and brackets. So parentheses are first, and I noticed that I've got parentheses and brackets. And in my order of grouping symbols, parentheses come first. So I'm going to draw a bridge under the parentheses, copy everything that's not on the bridge down on the second level, perform what's on the bridge, bring everything else down. Parentheses are done, so I'm going to move on to brackets. So I have brackets here, so I'm going to draw a bridge under there. And 10 plus 5 is 15, and everything that's not on the bridge comes down the next level. No braces, so I move on to exponents. There are none. Multiply and divide left to right, whichever comes first. There is none. Now I'm on adding and subtracting left to right, whichever comes first. So 15 minus 4 is 11, and there's my answer. Let's take a look at this one. This is a little bit more steps. So I've got parentheses and brackets and braces. Parentheses go first. So in this case, I'm going to do 1 plus, okay, I'm going to perform what's on the bridge. Everything else that's not on the bridge comes down. Now I still have another set of parentheses, so that's going to be my next bridge. Whoops. Let's erase that there. So what's not on the bridge is going to go next. Let's use a different color to show that's different. Okay, so what that on the bridge comes down. And then perform what's on the bridge. Make sure you're copying everything else from the step above it. Okay, now I've done all the parentheses, so brackets are next. So I'm going to do brackets. 9 minus, perform what's on the bridge, bring everything else down. Now, I have no more parentheses, no more brackets, but I have braces, and I have two operations in here. So I've got to kind of skip and move over. I'm going to go ahead and move down, and I can't do exponents because there are none. Multiplying and dividing, can't do any. So I'm add or subtract left to right. In this case, this subtraction comes first on the left. So I'm going to copy everything down. Whoops. Oh, wow. Made that a little weird looking. Okay, so what's not on the bridge comes down. Perform what's on the bridge and bring everything else down. All right, and then finally, the last step is one more, which is 2. We can get rid of the braces because there's nothing left to use. And the answer is 2. All right, now we're on to our last problem before you go and try these on your own. So I'm looking and I say parentheses are first, and I got parentheses and I have brackets. So I'm going to do the parentheses first. Everything that's not on the bridge comes down. Perform what's on the bridge. Now, brackets would come next. However, I have this exponent, so I have to perform that one next before I can perform what's in the brackets. So 10 squared is the same as saying 10 times 10, which is 100. And now I'm ready to move on to the brackets. So that's my next bridge. Everything that's not on the bridge falls down. Perform what's on the bridge. I can get rid of the brackets now because there's nothing else needed in there. And now I move on to, I've done my parentheses, I've done my exponents, multiply and divide left to right. There is none. Add and subtract left to right. Oh, here we go. And finally, the answer is 138. And that is how you use the bridge strategy to solve numerical expressions using the order of operations. Good luck!